In this video, we'll look at some advanced statistical functions. And the functions we'll be looking at are the standard deviation, correlation, and normal distribution. Without wasting much of our time, let's just go straight.
The first statistical function we'll be looking at is the standard deviation. And what is this standard deviation used for? You can use it to calculate the standard deviation of a range of numbers to show how they spread out from the mean. So let's look at, we have a table here containing details about some students, the number of hours they study for, their test 1 score, test 2 scores, and their attendance, which is in percentage. So we want to find the standard deviation. We said is the number of, is how the data, every of the scores, how they spread out from the mean of the score. So equal to ST. Now the formula to find standard deviation is STDEV. So we have STDEV-P, STDEV.S. STDEV.P can be used when you're working with the whole of the data, the whole population of your data. Why STDEV.S is has to do with you're working with the sample of your data. So in this case, this is all my data. It's not a sample. So I'm going to click on STDEV-P. I didn't mean I was working with a sample of my data, a sample, just a small portion of my data. I would have chose STDEV-S. But since I'm working with the whole data, I'll go with STDEV-P. And you can see calculate a standard deviation based on the entire population given as arguments. So I'll double click on this blue box. And the first argument is the number, then the second argument, follow. Going by that, you can see the dot. This means it is still number 1, number 2, number 3, 4, 5, 6, like that. So I'm just going to highlight the whole of the data, the values here in the test 1 score column. I'll hit enter. You can see we have 13.96 as our value for the standard deviation. If you try out your own, yours can have 13.96 something like looks like 6 or 5 to 6 decimal places, and you have to reduce it yourself. So let's calculate the mean. I want to show us something. To find the mean is using the average function, average of this data. Then I'll highlight the whole of this data to get my mean. So remember the definition of standard deviation, or what is this for? It can be used to find the standard deviation of a range or number to show how the number spread out from the mean, the distance from every of the data points to the mean. So here we have 75.9, which is our mean. This 75.9 is like a central point, a central score. It means most of the data points are around this value. They are around 75.9. So this standard deviation is saying that most of the scores here are either 13.96 below 75.9 or 13.96 above 75.9. So I think that's a lot, right? That's a lot. If you have the overall score is over 100, so if you have 75.9 as the average, and we have some scores that are 13.96 above 75.9, which means, so we're saying that let's start with our lower bound in this case now, which is for below. If I say 13.96 below 75.9, so subtracting 13.96 from 75.9 would have, so let's say equal to 75.9 minus 13.96. Now hit enter. Then I want to find my upper bound. Then I'm saying equal to 75.9 plus 13.96. So I'll hit enter. This is my upper bound. So I'm saying that most of the scores, the test score, is within this range, within 61.94 to 89.86. Most of them. So in this case, this standard deviation here is high. And what happens when you have high standard deviation? It means that the scores, there's a wide spread, there's a wide distance between the scores or the data points to the mean. There's a large distance. This is why if it had returned just, maybe the standard deviation was just 2, it returned 2 as the standard deviation. If you should look at adding 2 below 75.9 would give you something around 73.9 77.9, and above it will give you something around 77.9, right? So looking at this, it means that most of the students, they are trying to say that most of the students they almost have the same score. They almost have the same score. So once you have low standard deviation, small standard deviation, it means that the data points are similar. They are similar. They're almost the same thing. But if you have large standard deviation, large distance, it means that we have different values, different data points. Also, there's no how or no way you want to talk about standard deviation and you won't talk about the empirical rule, which states that 68% of your data falls within one standard deviation. Then 95% of your data falls within 2 standard deviation. 99.7% of the data falls within 3 standard deviation. So there's no how you will talk about STDEF that you won't talk about the empirical rule. So I think that's an assignment for you to go and work on. So go and check out the empirical rule and how it relates to standard deviation. So here now, since this standard deviation is 15.96, it means this is a high deviation, a very high deviation, and this means that most of the students, they perform differently, they have different scores. So, and it's true, since the first rule is that 68% of the data falls within one standard deviation, which if you count this, it falls within this range. 68% of the data will fall within this range. 61.94, 89.86, 68% will fall. This falls within the range. This falls within the range. 85 falls within the range. What else? 82 falls within the range. 68 falls within the range. 88 falls within the range. 80, 72, 70, 88, 82, 68. They fall within the range. So it's almost 68% of the data fall within that range. So check out the empirical rule and you understand STDEF much more better. So the next one we're looking at is correlation. What is correlation? Correlation is used to measure the strength of the relationship between two variables. And one thing you should know, if you're looking for correlation, if it returns 1, it means that there is a strong positive relationship between the two variables. If it returns 0, it means that there is no relationship at all. By strong positive relationship, I mean that an increase in one variable results to an increase in another variable. If it returns 0, it means that there is no relationship at all. So the variables are not connected. If it returns -1 or values close to -1, it means that there's a strong negative relationship. That is, as a variable is increasing, the other one is decreasing. So let's look at this. We have a column here for study hours and test 1 score. So I want to look at the relationship between, or the correlation between the study hours and the test score. So let's use we want to use the function correl, because to get correlation you use the function correl. You can see returns the correlation coefficient between two data sets. So I'll double click on this, and the first argument is the array, so that's the first variable you're working with, comma, and the next argument, which is array 2, is the second variable you're working with. Two variables involved is the study hour and the test score. I want to see how the study hour affects the test 1 score. So I'll hit enter. You can see this is 0.89, which is close to 1. It is close to 1. So it means that we have a positive correlation, a positive relationship, a strong one for that. Strong positive relationship. I need to say that an increase in the study hour results to increase in test 1 score, which means that this is to encourage our students more. If you've seen here that we have a 0.89 correlation, which is like a positive correlation, and this increase in the study hours results to increase in test score, it means that the more the student studies, the more they get high scores. So this will help us encourage them to study more, to study as much as they can, for them to have high scores in their test or their exam, because we've vet that the more they study, the more they have good grades. That is, so if it had returned maybe something around, if it returns 0 instead of 0.89, it means there's no relationship between the study hours and the test score. If it returns a value close to -1 or 1, it means that we have a negative relationship. An increase in study hour results in decrease in the test they get. So we'll start checking what's the problem. Why are these students studying for longer hours and they keep getting low results. So start checking out what the problem could be. Is it that they have to reduce the way they study and focus on other things? Or so this will help us focus on what to do. So that's that on correlation. So the next thing we're looking at is normal distribution. And what is it used for? Normal distribution will help us assess where a specific value stands relative to the overall distribution. So we want to know where a specific value stands, looking at all the distribution. So let's look at this. We want to look at where 78, this test score 78 stands in all the distribution. So I'm going to put equal to, so norm test score 78. So I'll double click on this blue box. Then the first argument is x, the test score you want to check the probability of. Then this comma. And the next argument is what is the mean. So the mean of the whole data we've calculated already, which is this comma. The next argument is the standard deviation, which we calculated here. Select this. And the last argument is, do you want to select cumulative distribution function or probability mass function? I want to select CDF, that's cumulative distribution function. I'll click on this and I'll close my parentheses and I'll hit enter. So I have 0.56. So one thing you should know about this, about normal distribution, if the result is 1 or any value close to 1, positive 1 I mean, it means that the score is high compared to the rest of the scores. So if it had returned maybe 0.6, 0.7, 0.8, 0.9, it means that that score is higher than the rest of the scores. But if it returns 0, it means that the score is low, very low compared to the rest of the data, the rest of the score. If it returns a value close to -1, it means that not -1, sorry. If it returns a value close to 0.5, not -1, 0.5, it means that that score falls around the median, the middle of the whole distribution itself. So in this case, now this is around 0.56, right? Around 0.56. So this means that, which is around 0.5. So which means that this person is having a score, this person's score falls within the middle or the median of the whole score. I don't know if you get what I'm trying to explain. So since this is 0.56, it means this score falls within the middle, the median. So let's say I want to sort this whole column. Let's see, I'm sorting. Let me sort based on let's sort this, sort from smallest to largest, so you can see, and it's 20. So let's look at the middle. The middle is going to be around I think, yes, 75 and 78. And you see that that's 10 and 11. Because when you count 1, 2, 3, 4, 5, 6, 7, 8, 9, then it's from 1, 2, 3, 4, 5, 6, 7, 8, right? And then we have over 20. So yes, this should be, yeah. So it's saying that this value falls, 78 falls within the median. The median, I can, if you look at it, it falls within the median. It falls within the median. All right. So that is that on the advanced statistical function. Please don't forget to practice as usual and share this video to those you know needs to watch this. Also, please try as much as possible as you practice. Also, try to read on these things. Read as much as you practice. Also, read, learn to read too. All right. See you in our next video. Do well to like and hit the subscribe button. Bye.